Today we're doing section 4.1, day 3, and we're going to be discussing coterminal angles. We actually are going to start with one more example on graphing. So notice our denominator is 3, so I'm going to make this be a negative 3 pi over 3. So this time halfway is going to be decimal, and that's okay. So I have negative 1.5 pi over 3. So every quadrant is going to go in increments of negative 1.5. So that means up here we're at negative 4.5 over 3. And we're going to hit negative 6 pi over 3. Now notice I haven't hit the negative 8, so I need to keep going. So negative 7.5 falls down here. And that means the next one will be 9 pi over 3. So now I know where 8's going to fall. So my initial side is at the 0. My terminal side is going to be in the third quadrant closer to the 9, because obviously 8's closer to 9. And the way the angle traveled is a negative angle, so I went clockwise, and I went one full time around, and then some. So sometimes when you have angles that are over one full revolution, you have to indicate that so I know how many times around you go on the axis. Excuse me. Alright, so moving on to new material. So now we're talking about coterminal angle. So a coterminal angle is an angle with the same terminal side. Okay, so hence the word coterminal. The terminal side falls in the same spot. What's different about it is that it has one revolution, I should say one or more, that separates them. So in general, if you're in degrees, you're either going to add or subtract 360 degrees to find a coterminal angle. If you're in radians, you're going to be adding or subtracting 2 pi. And there's infinite many coterminal angles, so usually they will specify what coterminal angle they're looking for. So, for example, in the next set of directions, the directions say find a coterminal angle that is positive and less than 360 or 2 pi. So that's how you kind of know, well, do I have to add 360 or do I subtract 360? So 470 is too large, so I definitely am going to be subtracting the 360 here. So my coterminal angle would be 110 degrees. They would fall in the same spot. Here this angle is negative, so I'm going to add 360. And when I do that, I get 240. So that's in degrees, pretty easy. Moving into radians, so we are going to have to work with getting common denominators. So for this one, I'm going to be subtracting 2 pi. In order to subtract this, I need to get common denominators. So I'm going to multiply this fraction top and bottom by 6, which is my denominator. So now I have 17 pi over 6 minus 12 pi over 6. And a lot of times students will ask me, well, like, how do you know when you're in radians, how do you know if you have to add or subtract? So notice, like, 12 pi over 6 is what 2 pi is equal to. So your answer has to be less than 12 pi over 6 in order for it to be less than 2 pi. So that's how you know if you have to add or subtract. So when I subtract, my coterminal angle will be 5 pi over 6. For number 4, obviously I have to add because I'm in the negative, so I'm adding 2 pi multiplied by 12 to get the common denominator. So I have negative 1 pi over 12 plus 24 pi over 12. And when I add them together, I get 23 pi over 12 for my coterminal angle. All right, that's all for today.